Good evening, one and all. This is Ted the Speedlearner here, and I am here to tell you what differentiation and antidifferentiation is. Now, I did an 8-part study on derivatives previously, okay? So some of this material is going to be very familiar to you. As I had stated before, we are letting delta x here and delta y represent 0, okay? So they're not, instead of putting the number 0 in, which is impossible because you literally cannot divide something with nothing, we're going to disguise the 0 as something else. In this case, we're going to disguise it as delta, all right? So first of all, we have an equation, y equals ax squared, all right? Now, we're going to add an unknown value to both y and to ax squared. Now that unknown value is 0, but we're not going to call it 0. We're going to call it something else. We're going to call it delta y and delta x. It's very important to do this because, remember, we cannot divide something by nothing. That's impossible. All right. So y plus delta y equals a times x plus delta x squared. Using the FOIL method, which is something I covered in a previous video, and if you don't know what I'm talking about, you need to go back to that video, the FOIL method, then come back here. All right? Using the FOIL method, we come up with y plus delta y equals a times x squared plus 2x delta x plus delta x squared. Now, we're going to actually take the letter a times every single one of these terms. And that gives us y plus delta y equaling ax squared plus 2ax delta x plus a delta x squared. All right. The next thing we're going to do is we're going to remove the original values, which is this y over here and the ax squared over here, because we already know that. We don't want those values in there anymore. We want the deltas. All right. So then we get delta y divided by delta x equaling 2ax delta x plus a delta x squared divided by delta x. Now I know that's a lot of stuff to remember here, but what we're doing is removing a delta x out of this equation. When we do, we get delta y divided by delta x equaling 2ax plus a delta x. Sorry. All right, now hold up just a little bit higher. Now, if we then say that delta x is 0, what we have left is delta y equaling 2ax. All right, so this is our derived equation from this original equation right here. All right, now, the original equation right here is called an integral. All right, and so we have a derivative of an integral right here. That's a lot of learning there.
Yes, sir.
All right. Now, when we go from the original equation, which is an integral, to the derived equation down here, we go through the process of differentiation. If we want to reverse that, we call that antidifferentiation. If we go from here back up to here, we call that antidifferentiation. Now you say, well, man, this is all complicated. We want a simpler way to solve all this. Well, if you noticed one little thing, you can solve these equations without all this extra gibberish. Notice here that the only difference between this equation here and this equation here, there's two differences, just two. One, this is multiplied by 2 and this one's not. And this one's x squared and this one's not. So, if you wanted to go from the original equation to this equation, which is differentiation, you would subtract 1 from the exponent here, and then multiply this by 2. If you wanted to reverse the process, you would divide this by 2 and add 1 to the exponent. And that's the way it works. You have to understand why we do what we do before we show you easier ways to do it. Otherwise, you'll never get the concept of what's being done. And that's what's important here. I know this was a tremendously long lesson, and I know you're going to have some problems working with this at first, but let me tell you something. When you finally get the true understanding of what we're doing, math will become a lot easier. All right, I will tell you more in a future video. Stay tuned.